the purpose of this presentation today is to go over the OpenGround integration that you're going to see in the civil products in 2024. And so we're going to kind of tag team this today. Marie and myself, I'm Derek, we're going to come in. We're both from the product management group. I'm on the civil side. Marie is on the Geotech side. And so what we want to do is we want to kind of show you both sides of the workflow, if you will, two different personas. Marie is going to kind of represent the geotechnical engineer who brings the data into the DGN file and does some things with it there. And then I will kind of come in as a civil engineer and then show some of the things that you can do with the data from there. And so we're going to start out with Marie. And so Marie, if you want to go ahead and take it from here. Now, before we do, just very quickly, we do need to read a disclaimer statement. Some of the stuff that we're going to be presenting here today is not commercially released. It will be out fairly soon, but it's not there today. And so we're basically kind of looking into the future and talking about some things that's going to be out there. So we're forward looking. And so just want to, obviously everything we're going to talk about, we have every intention of being in the product, and but because it is not yet released, we kind of want to make sure everybody understands that and doesn't make any purchase decisions based on what we talk about here today. So with that, I'll turn it over to Marie. She will be representing the geotechnical side of the equation as far as the geotechnical engineer, and she'll show you what you can do with OpenGround.
Thanks, Eric. Hello, everyone. To get started, let me say a few words about OpenGround. So this is our geotechnical information management solution that improves data quality and record consistency, enable greater collaboration, reduce data entry cost, maximize data reuse, increase data access, and also extend existing platform capabilities through its web API. So OpenGround is part of our subsurface portfolio and used by more than 15,000 users, managing more than 3 million boreholes so far. So now let's jump into today's topic, the OpenRoads Designer Geotechnical extension that will allow you to integrate subsurface information to your civil design process. So this new solution will let you visualize subsurface data in 2D and in 3D alongside the infrastructure design, integrate the subsurface to improve your deliverables such as long sections, cross-section views or sheets, and add any relevant information such as annotations and symbols based on your organization standards for comprehensive deliverables. For this to work, you'll need an OpenGround cloud access and one of the Bentley Civil Design 2024 products such as OpenRoads Designer, Rail, Bridge, Tunnel, or even OpenSite. So the Geotechnical extension is a separate installer that will be installed on top of the Bentley Civil Design products. So let's say I have OpenRoads Designer on my machine. The Geospatial extension will be installed on top of it from the OpenGround Cloud Launcher. So the OpenGround Cloud Launcher is downloaded from the Bentley Connect portal. And this is where you can install all the different apps to connect to your OpenGround Cloud instance. Once installed, the Geospatial extension workflow will be available from your OpenRoads Designer session. And the connection settings tool is used to connect to OpenGround, select a project, define the mapping between the OpenGround data and feature definitions. And this is a very important part because from this dialog, it's also possible to retrieve all the values from a specific property to create property-based symbology. So you'll be able to display your elements differently based on their property values. And by gathering this information from OpenGround directly here and creating element templates automatically, it helps to create different symbology more easily, avoiding a manual creation of multiple element templates, because we're doing this for you. So let's have a look at the first video here. So in this example, I'm using a DGN library file for my geotechnical feature definitions. That it's already set for me to display the geotechnical data in a standard way as defined by my organization. So as you can see, I have the geotechnical extension here, and I will connect to an OpenGround cloud instance I've been granted access to. From this connection setting, I can search and pick a project that I've been granted access to from the list. Then I can select the OpenGround data to be imported and map this data to civil feature definition. The civil feature definition list will let you pick an existing one from the DGN library file or the master file, or you can also create a new one automatically if it doesn't exist. Optionally, you can select a property from which the symbology will be created, as I mentioned before. And then once imported, the data is actually part of the design file with all its properties. Here you see the borehole location in plan view. And I switch to the 3D view. You can see the different soil layers and water level data being imported from OpenGround. Then in the new geospatial section under feature definitions in the Explorer, we have access to all the OpenGround features that are not part of this design file. They are imported, and we can see those different feature definitions here. The element templates dialog display the different folders used to create a property-based symbology. Here, the water level event, the different values were retrieved from OpenGround, so I could define different levels, different symbology based on their level event type. And a basic example is really the different soil type where different levels and patterning are used. So we leverage the symbology settings to specify which property of the element to be used for symbolization and select the element template folder that contains the different symbology for those elements, such as the color level patterning. So note that the property-based symbology can also be stored as part of your DGN library to share standards within the organizations, ensuring deliverables consistency. So it doesn't have to be done all the time when you connect to an OpenGround project. It can be defined once and then share within the organization through your DGN library and workspaces. So with the OpenGround extension, you're connected to your project in real time. So you can access any documents stored in OpenGround and link to a borehole location. And you can also display any borehole logs. So let's see it in action. So again, in OpenGround, one or many documents can be uploaded and linked to a borehole location. Usually it could be images, PDF, and this tool will query and list every attached document and display the selected one. So in this example, I just have one image and I can access it. The quick log functionality will display a PDF log for a specific borehole location. Different log templates can be used, allowing to visualize different components of a specific borehole location. So those templates are created and stored in OpenGround. So in this example here again, I'm picking the same borehole location, but I will select a different template. So I will visualize different components of the same borehole in a different log. They are dynamic, so those logs are generated on demand. That way you can be sure to access the most recent information as stored in the actual project. So it's not a static PDF linked to an element, a graphical element in your design file. It's really dynamic, generated on the OpenGround side. You can also refresh the data, and so you can just query and import changes from OpenGround. So you don't re-import everything all the time when you refresh the data. And in this example here, you'll see that I will edit data in OpenGround and then refresh it. So again, it will query the data from OpenGround based on actual selection from the connectivity dialog. So here I'm in the OpenGround Cloud Portal, and I will edit one of the elements. So I'll just edit simply the soil description of a specific element as an example and save this information. So it could be any edits, right? It could be, I could change the depth base, any properties of any elements in OpenGround, or edit it here and saved in the database. Then coming back to OpenRoads Designer, I will refresh the data and get the latest information. So if the depth of a specific element change, the graphic element will also reflect this change. In this example, I've just edited the description, and you can see that because I already had existing labels that was leveraging this information, it will automatically be updated as well to reflect this change and this new information. Okay. We do have the Create Terrain tool that will create a terrain model to represent a borehole location features, such as a specific lithology or the water level, for example. So in this example, you see that I'm creating a terrain based on the reading event call at time of drilling. And the create mesh will create a closed mesh element, for example, to represent the volumes of a specific topsoil layer, a specific layer. Let's have a look here. I'm using the Create Mesh tool to create a closed mesh from the limestone layer. And I will assign this closed mesh to the limestone feature definition to get some civil quantities for this specific material. I could also decide to create mesh and assign those to the same feature definition as well, to group a specific soil type, to create simplification depending on the level of details that you need. For example, if I just want to see the rock or everything else, let's say I want to create one mesh representing everything, I could also match those meshes to the same feature definition. That's it for me. So thanks, and over to you, Derek.
All right, thank you, Marie. So let me, yeah, there you go. Let me share my screen. Okay. All right, thank you, Marie. So if you may have heard, which is our older geotechnical application is being a couple of years, but we wanted to do this sooner rather than later to give people a chance to, to kind of acclimate to that and migrate to that. So you're kind of have both of them for a couple of years. So that's the first thing. The second thing is I want to point out that, so let's come back to Marie. So I've got a project, and let's say Marie is the geotechnical engineer on this project. So she has got the OpenGround extension. She is the one that has the ability to access the cloud, bring the data down, make those dynamic changes and things like that. But now let's say I've got a project here, roadway project, bridge project, whatever the case may be, and I've got, I don't know, 10 or 12 civil engineers working on it. Well, we all have access now. Once she's brought the data into the DGN file, we can integrate that DGN file into our project. We can go into that file. We can reference that file. We can use that data. Now, I don't need the extension. In other words, everything you're going to see me do is built into the civil products. And so I want to point that out. So everything you're going to see here is there's no extension required. You just need OpenRoads or OpenBridge or OpenRail or any of the other civil products. So what do I get as a civil engineer based on what she's already done? Well, I get borehole feature definition. So those got created automatically. That controls the display, but it also gives me the ability to control the width of the borehole. I may, I may want it to be different in 3D than it is in profile or cross section. So you'll see that. I get access to all the properties. I have a tool that allows me to project the borings onto my profiles. I get name boundary integration. The ability for my name boundaries to recognize where the boring data is and adjust the depth based on that. And then I get access through text favorites to annotation in plan, profile, and cross section. So this is what I just covered here. Is what you're going to see me do in the next few slides is there's no extension required. Everything is built in. So let's go ahead, Marie, and go to the next one. So let's start out with let's start out with this. So the first thing I get is I get access to all the properties. And that includes all the properties of the boring as a single entity. For example, who the driller was, the date they drilled, what their method was, different things like that, right? But I also get access to the individual strata information. All right, go ahead, Marie, and we'll go to the video that shows this. So you can see here, I'm in the file that Marie created, right? But I've just opened it up as a civil engineer. That should start automatically, Marie, but you may have to play it.
I think it's
and so you can see here, I'm in a 2D and I'm in a 2D and 3D view here. And if I go up under my workflows, notice there is a geotechnical workflow. But that's just Ghent, right? This is the same workflow. You're going to have the old Ghent workflow for a couple of years, but I don't need any additional workflow. Everything is built into the civil application. So if I want to go look at the properties of the borehole, you can see I can select that little circle or locator orb, and I get all the properties of the borehole as a single entity. At the same time, I can go access the individual strata, and I can dig down and look at the individual properties for shale or limestone or the individual one. So all of those properties are available to me as a civil engineer. Okay, Marie. The next thing we want to look at is the annotation. So we're sitting here, you just saw me in a 2D and a 3D view. So one of the things, all of the data stored on these borings are available to me through text favorites. And because of that, I can create text labels and basically create customized labels. Let's go take a look at the video, Marie, that shows this. So here I'm back in my file that Marie gave me, and I've got a 2D view and a 3D view. I'm just going to label the boreholes in 2D. So I've got a label created here using the text favorites that read the properties automatically from the boreholes. And again, I've just done something very simple. I labeled the borehole ID. I labeled the type. I labeled the final depth of the borehole, and I labeled the coordinates. But any other properties would be available to me, and I can customize those labels as I see fit. Okay, next, Marie. The next thing we want to look at is profiles. So you kind of seen how the boreholes are in plan in 3D, how we can access the properties, we can do some labels. Now, a lot of agencies and a lot of clients may have requirements for us to put our boreholes onto our profiles. Now, that necessitated the creation of a new tool. So under our vertical geometry tools, you're going to see a new tool called Project Boring Locations. And so it's going to project our borings onto our profile, but all of our properties and things like that will remain accessible to us for labeling. So let's go take a look at that, Marie. So I'm back in my file that Marie gave me, And I'm just going to go to a different view. Here I've got a 2D view on the left and a profile view on the right. Under my geometry tab, my profile creation tools, I'm going to select this new project boring, and I just identify the alignment, and then I'm just going to identify a few borings to project onto the profile tool, or onto my profile. And if I zoom in on these, you can see my feature definitions, my element templates, and everything have allowed me to visualize that the way I see. Now you'll notice that line that goes down the middle. That is a construction element, and that allows you to access all the properties of that borehole as a single entity. So these are the same properties you could access from the 3D or the 2D view. You can also access them inside the profile. But in addition, you can select any of the strata layers, and you can get the profiles for that as well. All right, next slide, Marie. Now, in addition, while we're in the profiles, let's go look at the profile name boundaries. So I've got my profiles on there, and maybe I want to include them on my profile sheets. So one of the things that we've done is that we've added a new option on the profile name boundary, which allows you to use projected points, and it's basically going to allow the name boundary tool to recognize the borings and make adjustments for them on the fly. Now, we also, while we were in there, the way that we implemented this actually gives you some additional functionality. So not only will the name boundary now recognize soil borings, it's also going to recognize other projected elements as well, such as drainage nodes or other types of crossing points. So let's go ahead and look at that video, Marie. So here I am. I'm going to go back into my my same file. I've got my profile view, and I'm going to clip some sheets out. And so I'm going to open the name boundary tool. I'm going to open the profile. I've got my seed. And notice I'm just going to place a name boundary without that new option enabled. Now notice the name boundary does not recognize my borings. This is the way it works in the past. It just looks at the existing ground. It just looks at the proposed profile. But notice over there on the dialog, we've got this new option called Use Projected Points. And it allows the name boundary to shift automatically. And again, notice it also works not only for borings, but drainage nodes and other crossing points. Now notice what happens when I enable this. Automatically, the name boundary is going to recognize those borings, and it's going to adjust its depth to fit on there automatically, okay, if that is enabled. And so I'm going to say okay, and we'll go ahead and clip this out. And when I do, you'll notice that everything looks great on the sheet. So this is a new option that we've added, again, which allows your name boundaries to recognize your borings automatically. All right, let's go to the next one, Marie. Now, while we're in the talking about profiles, we've got our borings onto our profiles. We've cut them out. We've put them on our sheets. Now let's go look at some annotation. Let's go look at some annotation and see how that works. Okay, Marie, next slide. So I'm sitting in my my profile sheet that we just saw. And what I want to do here is I want to go back over to my drawing model. So here's my drawing model. You can see here my profiles here. Notice I've got the individual stratas as well as that construction element that I can use to access properties. So I'm going to come in here and I want to label the boring ID. Now the boring ID is just a property of the boring as a whole, and so to label that, I'm just going to identify that construction element. But I can also identify the individual layers and go in and label the profile there as well. And so again, just as we saw earlier with labeling the 2D, all of your properties are still available in the profile view and accessible for you to use to create labels. All right, next one, Marie. All right, let's talk about cross-section name boundaries. And so we also made some changes here. So there were two things that we needed to do with cross-section name boundaries. The first one is we wanted to make it easier for for you as a user and for the software to be able to find the name boundaries and place the name boundaries properly in the correct horizontal location, right? So instead of you having to go out and find out what the station of the name boundaries are and create a name boundary at that station, we wanted to automate the horizontal placement of those. But at the same time, we also wanted to be able to read the depth of the profile of the cross sections and make sure the name boundaries adjust automatically. Now, to do that, we decided to use an existing MicroStation functionality called name groups. And these name groups can be created in both 2D and in 3D. And then you'll notice at the bottom left, at the screen grab there, you now have the ability to select the name group, and then you can use the option called name groups only. So let me explain what name groups only is. So basically, let's say I come in and I want to cut some cross sections. I want to start at 0 and go to the end of my alignment, and I want to place cross sections every 25 feet, right? Well, I can choose a name group of my boring locations, and it would add that to those locations as well. Or I can just say, hey, I just want to create cross sections at the name group points only. And so you can kind of combine the name group locations with intervals and other ways, or you can just do those by themselves. So let's go take a look and see how this functionality works with cross sections. Okay, Marie. So here I am. I am in my my Geotech file that Marie gave me. I've got a 2D view and a 3D view, and I'm going to open up the name group dialog. Now, the name groups exist in the model themselves, and I want to show you this because this is important. So I'm going to do a little bit of training here if I can. So I'm in my 2D view. Notice the focus is on it, and I'm going to create a name group called 2D cross sections. Now, I'm going to use a graphical filter that's automatically going to find all of the borings, and it'll put them into a selection set automatically. And then I just hit a data, I just say add those elements to the name group. So I just created a name group in the 2D view that has all of my borings. Now I'm going to do the same thing in the 3D view. Okay, now I'm doing this for a reason because I want to show you something. You don't necessarily have to do this, but I just want you to see what happens. So I'm going to put the focus on my 3D view. Now notice this name group is going to exist in that view. So once again, I'm going to create a name group. I'm going to call it 3D cross sections. I'm going to use my graphical filter. You can see all the little circles there. Automatically, all 11 of them got picked up. And I'm just going to go back over to the name group dialog, and I'm going to say add all of those to my name group. So once again, I'm in my Geotech file. I've created this name group using graphical filters. I've got one name group in my 2D view, and I've got another name, in my 2D model, and I've got another one in my 3D model. Now, let's go look at some cross sections. Here I am in a cross section sheets file. It's just a container file. I've referenced everything in, and I've got it set up in a 2D and a 3D view. So I'm going to open my name boundary. I'm going to select my cross-section option and my drawing seed. And then notice you've got a new option there that says name group. Now, name groups it reads them across reference files, so it's reading them from the OpenGround file that I've got, and it reads both the 2D and the 3D. And again, I'm just showing you here the different options. So I'm going to select the 2D to start with just to show you what happens. And so I select the 2D, and I'm going to say just place name boundaries at the name group points only. And so you can see there along my bridge, the name boundaries have been placed properly horizontally. But notice they did not take into account the depth of the boring. The reason for that is because I used a 2D name group. I created that name group from 2D points in a 2D model. So it has no elevations to go by, right? So if I go through here now and I create my cross sections, they're going to create properly at the right locations. But you're going to notice when we open the drawing model that the borings themselves are not accounted for. They're just cut off, right? This would just be the way it would work today. It just uses the existing ground, it uses the proposed corridor, and it figures out the depth the best that it can do. Well, that's not what we want, right? We might want it to account for the actual depth of those borings. So let's go in there and let's do it again. So this time I'm going to go back to my drawing, my name boundary tool again. I'm going to do everything the same, but this time I'm going to select a 3D named group. Now, because I used 3D, that was 3D points. It's able to pick up 3D elevations. Now, notice when I place my name groups, not only are they correct horizontally, but now they've adjusted themselves vertically to take in the full depth of each of those soil borings, right? So again, I just wanted to point that out. So now notice what happens if I go in and say, okay, let's create some cross-section drawings from those name boundaries. Now you'll notice the difference. Now those name boundaries take in the full depth of each of those borings. So again, this is a difference between using a 2D name group and a 3D name group. So you might want to file that away. And again, obviously, if you want the borings to show up, you'd want to use a 3D group every time. And just kind of wanted to point that out because I thought it was important. All right, next one, Marie. All right, the final thing I think I want to look at here is just to point out the fact that, you know, Marie showed this early. You've seen this a couple times already, but one of the great things about using OpenGround is that when you bring it in, you get feature definitions, you get symbology settings. So you've already seen both in cross-section and profile and 3D how you control what you want things to look. If you want to use hatching, if you want to use some type of material or whatever, you have the ability to do that. Next slide, Marie. But one of the things that we've given you in your feature symbology settings is the ability to adjust the boring width display. And this is important because you think about out in the field. In reality, I mean, I'm not a geotechnical guy. I don't know how actually wide the drill when you put in a core. And is it 8 inches? Is it 10 inches? Is it 12 inches? I'm not sure, but I can tell you if you actually put it in the real depth on the set of plans, you wouldn't be able to read it. So you as a user may want to adjust the depth in 3D or in profile or in cross sections, and so that it's just readable on a set of plans. And so we've given you the ability to do that inside your geotechnical symbology settings. So let me just show you how this works. So Marie, next slide. I think this will be our final video here. So here I'm coming back into our cross section here, and let's say, for example, you can see that our borings look really wide, right? I mean, they're not half the roadway or half the bridge width, but they're certainly pretty wide. So I'm going to go back over into the Geotech file where the features actually are, and I'm going to go into the OpenRail standards, and I'm going to go down to the symbology settings, and I'm going to go look at the geology code and open the properties. And here you'll notice that this is where you have the ability to control the width for 3D, for profile, or for cross-section. And now it's set to, in cross-section, it's set to 5, so that's 5 feet or 5 meters, depending on what workspace you're in. And I'm going to set that to 2 because they're too wide. So all I have to do now is go back into that cross-section file, and when I open up that drawing model, it'll make the adjustment automatically. And so you can control that width and make it look on the plans the way that you want it to look. Okay, next slide, Marie. All right, the final thing we want to look at is cross-section annotation. So we've looked at our annotation in plan. We've looked at our annotation inside the profile. And the final thing, of course, as I just said, is we want to look at the annotation in the cross-section. This is very, very similar to what you saw inside the profile, right? You'll notice, if you notice the screen grab right there, whenever you slice through it, either in profile or in cross-section, we're going to give you a line that goes down the middle. It's a construction line, but that allows you to select that and access all the properties of the boring as a single entity, or as you saw in profile, you can also access the individual strata layers and get the properties from that as well. So our final video, Marie, if you want to go there. So here we are back inside of a cross-section file, and I'm just going to zoom in up here so we can see this a little better. So here's a boring or a couple of borings, and I want to label them. So the first thing I want to do is I want to just label the boring ID. Now that is a property of the boring as a whole. So I'm just going to hit place, and what I'm going to do is I'm going to ID that line, because that gives me the properties of the that I need for the boring as a single entity. And so again, I'm just going to select the boring ID here. I select that little line, and that reads those properties, and that gives me the boring ID for that one. And I'll also go ahead and do the other one as well while I'm at it. And so again, that line is very important, again, because it gives you access to those properties. Now, if I want to label the individual strata, I can do that by selecting the strata. So maybe, and you can customize these labels to do whatever you want to do. So for example, let's just say I want to create a simple boring label that just has the type, the top depth, and the bottom depth. So here I've used one, I've created a label there to do that. Maybe I want to add a label with a description in it. So I've created a second label called cross-section strata label with descriptions. I'll identify a different strata label or strata here in the boring, and I'll label that as well. So these are, again, all of these properties are available to you as text favorites. Each one of those you can choose to create those in labels and not. And by the way, those properties are available for other things as well, such as reporting or display styles. And we're just kind of showing them through the text favorites today. As we do. Okay, next slide. And I think that, if I remember correctly, wraps it up, and that covers everything that we wanted to cover today. So we really appreciate you guys taking the time to join us